Hello everyone, I'm Swastika Datta, a generative AI solutions architect at NVIDIA. Today I'll walk you through the Telco Network Configuration Blueprint. It is designed to be very simple to set up. Whether you launch it with Brev or clone from GitHub, you'll be up and running in just a few steps. We will quickly go through the overview and architecture and then see how to set it up. And finally, we'll do a hands-on walkthrough of how you can use it. Let us start with the overview. This agentic AI blueprint by NVIDIA intelligently tunes radio access network configurations at the cell site level, and it is adaptable beyond RAN as well. It operates on top of BubbleRAN's 5G O-RAN network platform, which gives us a dynamic, real-world testbed. As the system runs, it observes key network stats like signal-to-noise ratio, modulation and coding scheme, LDPC, and other stats that matter in high-performance wireless links. The core value here is reasoning and data-driven decisions. It understands trade-offs. For instance, it can balance between improving downlink bitrate and potential SNR degradation. This agentic blueprint is built with LangGraph's agentic framework, which manages a group of specialized LLM-based agents. Each agent focuses on one piece of the workflow: monitoring, configuration, or validation, and they work together to make intelligent decisions. For more details, please check out the accompanying blog, build.nvidia page, and the GitHub linked below. Now let us talk about the architecture. This architecture represents the agentic AI blueprint workflow. On the left, we have BubbleRAN's 5G O-RAN platform, which simulates a real-world end-to-end network. It feeds the system with real-time network stats like SNR, MCS, LDPC, and others. There are three agents in this blueprint: the config planner agent, the validation agent, and the monitoring agent. All of them are built using LangGraph and powered by Llama 3.170B NIM. It enables structured reasoning and decision making across time. The user can query the optimal value of a specific parameter through the user interface. The config planner then handles this query by analyzing performance KPIs and historical configuration data from the BubbleRAN environment. It returns these insights and suggestions to the user. Once the user approves a suggestion and chooses to validate the recommended config, the validation agent applies the change to the network. It monitors real-time KPIs, decides whether to keep or revert the new parameter value based on the performance change. There's also this monitoring agent. It keeps watch over key parameters continuously. If performance dips, it alerts the user and can handle control back to the config planner to re-optimize. This flow keeps the user in control while automating the heavy lifting. It helps to make the data-driven network tuning faster, safer, and extensible to other domains as well. Now let us talk about the different ways you can set up this blueprint. You can either deploy a Brev launchable or clone the GitHub in your system. First, let us start with the Brev launchable. Brev launchable is a pre-configured GPU-enabled environment that can be quickly deployed and shared. Basically, it is like a ready-to-use computer setup in the cloud that you can start with just one click. You can locate the Brev launchable link for this blueprint in the build.nvidia page. Once you click on the Brev link, you should be able to see this launchable page with the Jupyter Notebook review for quick setup. First, we will click on Deploy Launchable button. It might take a few minutes to set up the GPU and the virtual machine environment. Let us fast forward through this. Finally, we can access the notebook. Click on this View Instance link and scroll down. Now click on the link to port 8888, which is the default Jupyter Notebook port. Now we can open this notebook for setting up this blueprint. The first step is to clone the repository. For the second step, we need to set up the environmental variables. We need NVIDIA API key to run this blueprint. This API key provides you access to the endpoints of different LLMs, different NIMs, and NVIDIA registries. If you do not have an API key, it is very easy to create one. Navigate to the build.nvidia webpage and create an account. Since I already have an account and logged into it, I can just click on this Get API Key button and then click on Generate API Key button. Please make sure to save this key securely since it is shown to you only once. Now copy this key and navigate back to the notebook. Go to this directory and open this config.yml file. Please make sure to insert your API key over here. After inserting this API key, you should save this file. And then you can run this cell. This blueprint allows you to access LLM either via the NVIDIA API catalog or the locally hosted Llama 3.1 70B NIM. If you are in a hurry and want a very quick deployment, you can skip the step 3. Since we already have GPU here in this launchable, I will deploy the NIMs. It provides better performance, latency, and privacy. It takes around 5 to 10 minutes to start for the first time. Now we run the NIM container. This step might take a few minutes to complete. We can monitor the status of this container by running this cell. Once it is ready, it should output this statement. Now we can see our NIM is ready to use. Since we want to use the locally hosted NIM, we can set the NIM mode equal to true. And now we just follow the next steps. This step sets up your Python virtual environment. Finally, we can start the Streamlit UI. The Streamlit app is available in our browser, and to access it, we navigate back to the launchable page and refresh it. Scroll down, and now you can see that this port 8501 is available. And now you see our UI is ready to access. Now, before going through the walkthrough of how to use this blueprint, I will go through the alternate method of setting up this blueprint by cloning from GitHub. Before proceeding with this method, please make sure to check out the requirements section in GitHub. To set up this blueprint, you must meet the requirements for both the LLM agentic workflow as well as the BubbleRAN network. If you do not have GPUs, you can use the NVIDIA API endpoints. However, if you do have GPU and meet the requirements for hosting Llama 3.170b NIM, we strongly recommend using the locally hosted NIMs for better performance. Now we can navigate to the Quick Start section. As the first step, we need to export the NVIDIA API key. As mentioned earlier, if you do not have API key, you can easily generate one. One of the easiest methods is to navigate to build.nvidia webpage and create and log into your account. Since I already have signed into my account, I can just click on this Manage API Key or Get API Key button, and then I can generate my API key. Remember to save this API key securely since it is shown only once. Finally, I can export this API key in the terminal. There's also a good time to start your local NIM if you choose to do so. You can follow the instructions here to start your NIM. Since I already showed how to deploy the NIM in Brev Launchable, I will skip this step here, and I will just proceed with the NVIDIA Catalog API endpoints. Now moving on to the second step, setting up this repository. Let us clone this repository. Once this is cloned, it is mandatory to insert our NVIDIA API key in the config.yml file over here. Now there are two other important variables to note. By default, the network starts with RF SIM mode, which simulates 5G user equipment. If you wish to deploy the blueprint in USRP mode to connect an actual physical user equipment, please refer to the documentations on how to connect your physical UE to the network and then set this variable to the USRP mode. Another important variable is the NIM mode. As mentioned earlier, this blueprint allows you to access LLM either via the NVIDIA API catalog or via the locally hosted NIMs. If you want to use the NVIDIA API catalog endpoints, you can leave this config LLM section as it is. However, if you want to host the NIMs locally, please start your NIM and then set this NIM mode to true. The rest of the values can also be changed if needed. Please refer to the GitHub for more details. Now, going back to step 3, deploying the application. We can choose any of the options depending on what is most suitable for us. Option 1 is to deploy on bare metal with Python virtual environment. First, let us create and activate this virtual environment. Then we can install the requirements. Finally, we can just run the Streamlit application. We can see this application is started and running on this board. Let us stop this and see the other method of deploying. The other method is to deploy with Docker. For this, ensure that you have the latest Docker engine and Docker Compose installed, and then we can just run this command. We can see that the application has started. And finally, for the third option, we can choose to deploy with Jupyter Notebook, very similar to how we used in the Brev launchable. Finally, once it has started, I can access this port. Since I'm using VS Code on a remote system, I have forwarded the server's localhost port to my local machine so that I can open the UI in my browser as if I was running locally. If you're stuck in any step, it is a good idea to check out the known issues and troubleshooting section in the GitHub. It covers the most common issues and how to resolve them quickly. Now that we discussed all the different ways to set up this blueprint, let us quickly walk through how you can use this application. On the left-hand side over here, you can see the different parameters supported by this blueprint. To interact with the BubbleRAN network, we must first start it. Here we click on the Start Network button. This starts the BubbleRAN 5G O-RAN network in the background. It takes a few minutes to start up. Now that the network is running, I can query the config planner about the different parameters. I can ask it to suggest me the best value of P0 nominal. Then I click on the Process Query button. It is now reasoning through the different values and creating SQL queries to analyze the historical KPI databases. It calculates the average KPIs and the weighted gain based on these given weights. After reasoning, it generates the summary of insights and reasoning here. Here is the average KPI table and the weighted average table. Finally, after reasoning, it suggests us that the optimal value is -86. Now I can click on this Make Changes and Validate button. This passes the control over to the validation agent. The validation agent restarts the network with this new parameter. It observes the real-time KPIs recorded from the BubbleRAN environment for the given amount of time, which is 10 seconds over here. If the weighted average gain degrades, it reverts back to the original value. We see that the configuration was optimal and stable, with positive weighted gain observed. The P0 nominal value has been updated in this panel as well. Now, we can also monitor the weighted average gains corresponding to different parameters by clicking on this Monitor Network button. If any of the weighted average value degrades, the monitoring agent will prompt the user and pass the control back to the config planner for re-optimization. To save our time, I will stop the monitoring for now. Some other values of interest are the monitoring time and the validation time. These variables control the time period of observing real-time KPIs by monitoring and validation agents respectively. You can choose a value from the drop-down list. We also have this Add Traffic button to simulate busy network conditions. You can select the traffic time you want and the traffic bandwidth and click on Add Traffic button. Finally, to stop the BubbleRAN network, we click on the Stop button. To fully restart the environment and databases for a fresh start, we can click on the Reset button. We can also manually change the values of different parameters using this drop-down list. We select the value from the drop-down list and click on Start Network to apply all the changes. With that, we can wrap up the walkthrough. Thank you so much for joining this demo of Telco Network Configuration Blueprint. I hope it gave you a clear idea of how this agentic AI blueprint powered by NVIDIA NIM and LangGraph can be used to drive real-time intelligent network configuration. It runs on top of BubbleRAN's 5G O-RAN platform, which provides a powerful and flexible simulation environment for wireless networks. You can explore more via the GitHub repository or the build.nvidia page. If you have any questions or ideas for extending this, please reach out to us. Thank you so much once again.